going to solve around 20 questions in each topic, previously CBSE question. I've tried to take different kinds of questions and good questions. So I'm going to start with this topic, that is applications of derivatives. So let us start with our very first question. Okay, so the question says a ladder is 5 meters long. Let's lean against a wall. Okay, the bottom. Okay, so let us make the diagram. So let us suppose this is the wall and this is the ground, and this is the ladder which is leaning. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeters per second. So this is the bottom, and it is pulled at the rate of 2 centimeters per second. How fast is the height on the wall decreasing when the foot of the ladder is 4 meters away from the wall? So before starting any problem, we'll try our best to visualize what the problem is saying by making a small sort of diagram. Okay, so what we need to find is this height. No, not this height. At what rate this height is decreasing? How fast is its height on the wall decreasing? Okay, so rate of height. So basically dh by dt. We need to find out. Okay. Obviously, when this ladder is, since the ladder is rigid, so when it will shift toward this side, then obviously the height is going to decrease like this only. Okay. And what do we know? We know the length, which is 5 meters. Okay. And we know this. And we want the rate of height. Okay. Okay, let's consider this as h and this is at x bottom. X is, so what we are given is dx by dt. We are given, which is 2 centimeters per second. Okay. And we need to find dh by dt when x is equal to 4 meters. Mind the unit, this is centimeter and this is meter. Okay. And we know the length of the ladder, which is 5 meters. Okay. So firstly, okay. So let us try to write the expression for h. Okay. Expression in terms of h and x. Because then only we'll firstly make an expression, then we'll derivate, and then that's how we are going to, like, basically we have to, why I'm saying all this is to build up the thought process that how you should proceed. So we know this is a right angle triangle because the wall is perpendicular. So this is going to be the height, and this is, let us suppose it's initially at some sort of, this length is x. Okay, let us assume. Okay, because we need to find that particular instant of, like, when x is 4, x is not 4 initially. That is quite obvious, so we should not assume. So since it's a right angle triangle, so we can apply Pythagoras theorem, which says h square plus x square is going to be L square, which is 25. We know. Okay, so this is the expression, so I'll simplify it. X square plus x square is 25. Okay, so let us differentiating on both sides. On both sides with respect to time, because that's what we have to find. Okay, so what is the differentiation of h square? It's 2h, firstly this expression and then the inside one. That is going to be dh by dt. Same thing. Similarly, this thing, 2x into dx by dt. And since 25 is a constant, so its derivative is going to be 0. Okay, so initially we are provided with some sort of information. So we know dx by dt, we know x. And do we know h? Yeah, we know h actually. Because we know when this is 4 and we know the length of the rod is not going to change. So we can calculate h, right? At that instant. So let me just do it here only. So sometimes they're not going to give you complete information. It will just be, you need to apply some common sense. Square is going to be 25 minus x square, which is going to be 25 minus 16, that is going to be 9. Okay, then h is going to be root of 9, which is going to be 3. That's how. So we know h is equal to 3 also. It was not given, but we used our common sense. Okay, let's go down. Sorry, what's happening? Yes. Okay, now we know everything. I'll simply substitute it. What was dx by dt? Dx by dt, sorry. 2. Okay. So if I'm going to put dx by dt 2 centimeter per second, then we are going to get dx by dt also in centimeter per second units. Okay. So mind that, because the units of h and x are going to cancel. So and this 2 is also going to be cancelled. So dx by dt is going to be minus x dx by dt into 1 by h. First we will shift this here and then shift h. Okay, so let me just substitute the values. So x is 4, dx by dt is 2, and 1 by h, so x we calculated, which is 3. And the unit is going to be centimeter per second. So dh by dt comes to be minus 8 by 3 centimeter per second, which is our answer. And we kind of, we can guess that dh by dt is going to be negative because this thing is decreasing. So that gives us a feeling that yes, it's going to be negative, and we got it. So we are correct. And this will increase. It's positive too. So let us move on to our next question. Okay. So the question says the amount of pollution content at a linear in a city with 2x diesel vehicles is given by px, and find the marginal increase in pollution content when 3 diesel vehicles are added, and write each value indicated. Okay, so this word in AOD is CBSE's favorite. Okay, marginal. This word can be used in any other form, I mean in any other question, not necessarily for diesel vehicles. Basically, you will be given some function, which is this, and when you see the word marginal, what we have to do, basically we have to differentiate the function, okay, and substitute the value which is given. Okay, so simply px is our function. To find marginal increase, I'm just going to differentiate it. Very simple. Plus 30. For this we need to calculate that x is equal to 3. Okay, so just substitute and you'll get the answer. Very simple. Okay, so next question is find the intervals in which fx is strictly increasing and strictly decreasing. So this is one of the regular question which comes very often in CBSE exam. So this is our 4-degree polynomial, and we need to find the intervals in which. Okay, so firstly I'm going to go with a competitive examination method, which is you can take it as a shortcut or to check your answer, but don't do this method in paper because CBSE, they prefer everything to be written and no shortcuts. Okay, increasing or strictly decreasing. So what's the definition of strictly increasing? So function is said to be strictly increasing if the derivative of the function in the given interval is greater than 0, and strictly decreasing when derivative is less than 0 in that particular interval. Okay, so basically I'm going to get an idea through a shortcut which many of you might be knowing, and if not a problem, I'm going to show you anyways. So the shortcut is that firstly we are going to differentiate the function, which is going to be 12x cubed minus 12x squared minus 24x, and 5 is going to be 0. Okay, and then I'm going to find one root of this equation to hit that value, and I can clearly see it's 1, or maybe not, minus 1. Yes, minus 1 is the root of the equation. So it's equal to minus 1 is the root, so we are going to bring the constant term here, and then we are going to factorize this expression using this thing. Okay, so how we are going to do it? So firstly we are going to see the degree of the polynomial, which is 3. So we are going to write this thing 3 times. X plus 1, x plus 1, x plus 1. Then we are using these three, we are going to somehow make this function again. So it might seem a bit confusing, but you'll get to know. So we need to firstly make 12x cubed. So how we are going to make through this? Simply multiplying it by 12x square, but then we'll get one extra 12x square here also. And we need here minus 12x square. So how we are going to get it? Simply making 24x minus 24x square here. Then it will become minus 12x square. Okay, so here we are getting minus 24x. Usually we might need this thing also, but in this question it's resolving here only. So plus 0. Okay, so we are going to take plus 1 common and probably 12 also common. And we can see we are getting here x square minus 2x. And then we'll take x also as common. Plus 1 x minus 2. So this is the factorization of f dash x. Okay, so we are going to make number line sort of thing, number line. And so we're going to make these three 0 individually. The expression which are in multiplication. So x is equal to 0, x plus 1 is equal to 0, x minus 2 is equal to 0. So this is simply x is equal to 0. So let me put it here. And this is giving us x is equal to minus 1. This will be somewhere here. And this is going to give us x is equal to 2. Okay. This is here. Okay. So we need to focus on this thing. So when, let us suppose, think of a number which is greater than 2, probably 4. So we'll substitute 4 in this expression and we'll see that when while we are putting 4 is at dash 4 greater than 0 or less than 0. I think any number which say we are going to put greater than 2 here, because these are anyways positive if we are going to put a positive number. So the overall expression is going to be positive only if we put any number greater than 2, even 2.01. So we'll put the sign of the function. Function is positive, so we're going to put positive sign in this interval. Okay, so from 0 to 2, let us put 1 and let's see. So 1, 1, 1. So these things are positive, but 1 minus 2 is negative. So negative. Then minus 1, between minus 1 and 0. Minus 1 by 2, let's put that. So minus 1 by 2, it is positive, but it will be negative, and this is also going to be negative. So overall, it is going to be positive, and you'll notice here it is going to be negative. Okay, so we'll see the sign of the function, and we'll just put plus minus here. So what this symbols means? So that means we get our answer basically. That's what we need to find. So for a part, we need to find increasing. So we can write in intervals minus 1, 0, and in this interval, union to infinity, and minus 1, or minus infinity. It's not going to be square, open, and minus 1, union. I think we should not include minus 1, because minus 1, 0, so it's close only. Union 0, and 2. So here the function is going to be decreasing since f dash x is decreasing here in this interval. So this is, so through this method we'll get a rough idea what our correct answers are. So up from the starting till here, you don't have to use this method. Yes, I think you are surprised, but yes, don't use in CBSE, because they're certainly not going to give you marks because it's a shortcut. Okay, this is a shortcut particularly. Okay, so how in CBSE you have to do? Yeah, you are going to do till here and till here also. Then we are going to show that at these intervals we are going to break the function and see. Then you have to make one graph. Okay. So not graph, one table. So when x is going to be less than 1, minus 1, when x is going to be between minus 1 and 0, and x is going to be between 0 and 2, and when x is going to be between when x is going to be greater than 2. That's satisfied. Okay, so till here you can, this is basically a shortcut. Okay, you can just c plus minus, but don't do that in CBSE. Do till the finding the factorizing the derivative, and then here you are going to write fx. Okay, make it properly. So now we need to make 4 cases. I won't be solving all of them. Then you have to write like this: case 1, when x is less than minus 1. Then you have to assume let x is equal to minus 2. Okay, and then you're going to check f dash of minus 2 there, and you're going to say whether it's positive or negative. Then you're going to fill this table. So basically you have to make 4 cases, and we have to take one example each and find the sign of the function and plot it here. Okay, so you have to do till all that step, and then finally you have to write the interval, this answer. Okay, so I told you what to do. Make it very nicely, do it very nicely, and you'll get full marks. Switching to next question. So the question says find the value of x for which this is an increasing function. Okay, so we need to find the intervals. Basically, it's not, we have to, the question does not will not tell you everything. You have to extract out of it. So basically it's saying that tell me the interval in which this function is going to be an increasing function. That means tell me in which interval the derivative is going to be greater than 0. Okay, so this is going to be our y. So as or we can write it as fx also, because it's a function of x only. So we are going to do this. It's like we did in previous question. So we are going to derivate it. Minus 2 2x squared minus 2x. And then we are going to derivate this thing, children. 2x minus 2. Okay. So don't open this. Some students do this, like they open this bracket x squared minus 2x. Okay. And then they solve this, they open this bracket also, and then they find the derivative. You won't get a proper factorized answer if you do this. It will just be a waste of time, because it will take time to factorize. So you still will, you will save a lot of time. Okay. So what we can do further is take x out here. Sorry. And take 2 here, so it will be 4. X minus 1. Okay. So again, using a shortcut. So we'll get 0 into when we put this expression to 0. Okay. So these sides we are going to get, and we know the answer. 0 to 1 and 2 to infinity. Again, we have to make the table and check for all 4 cases. Okay. And then write the final answer. Don't forget to write the final answer. Then only you are going to get full marks. So the answer is, this question is 0 to 1 and 2 to infinity. So next question is find the intervals in which the function is increasing, okay, and decreasing. So sin x plus cos x is kind of CBSE's favorite. They can change the interval, but this expression is certainly their favorite. Okay, so I would not like to play with both sin x and cos x, so I will reduce the function. I will multiply divided by root 2. And why I did, you will get one also. Okay. So 1 by root 2 is sine pi by 4, or also cos pi by 4. Now I am writing here cos because it is going to be our benefit. Sine pi by 4 and cos x. So I think we are cool till now. Okay, so what we can see, this is sine A, cos B, sine A. Okay, so which is sine A plus B, isn't it? So now our function is reduced to root 2 sine of x plus pi by 4. So now we need to work on this function. Okay. In which interval 0 to 2 pi. Okay. Sorry. So, you know, x is from 0 till 2 pi. When we define function, okay. So we'll add pi by 4 on both sides. So x plus pi by 4 is going to go from here to here. Okay. Okay. So, so let us substitute x plus pi by 4 as some constant t. So if t is equal to root 2 sin t, where t is from pi by 4 till 2 pi plus pi by 4. Okay. So now our question is reduced to this, that we need to find where this function is increasing or decreasing. Okay. So we find the intervals for t, and then we will substitute again t as x plus pi by 4, and then finally we get the intervals of x, because basically we need to find the interval of x, not t. Okay. Sometimes what students do, that they substitute and then they forgot and they write in terms of t only, so they do not get full marks. So okay. So let me try to analyze this visually. Okay. Since I know t is positive only, so I'm going to consider this side only. Okay, okay, okay. This is pi. This is 2 pi. This is 3 pi, and so this will be pi by 2, this gap. So 2 pi plus pi by 4 will be somewhere till here. Let me use a different color. So we need to analyze our function root sine t, root 2 sine t, till this red line. Okay. And if you want this, you can have this too. We're not concerned with that, but we can make the graph completely. Okay. Okay. So, okay, we didn't need to do that. Why? Because we need to check f dash t. So which is root 2 cos t. Sorry, this was unnecessary. We need to analyze this function in this interval. Remember not to make the same mistake. You can make, I mean, making sine graph is not that useful, but yeah, we want to analyze this. So that is our only condition, as we discussed in previous questions. We need to find where derivative of function is increasing or decreasing. Then only we'll be able to find. So I'm going to make the graph of cos t. Okay, so this is pi by 2. This is 3 pi by 2. This is pi. This is 2 pi. And since this interval is pi by 2, so 2 pi plus pi by 4 is going to be somewhere here. Okay, let me draw the red line. So we need to analyze the function till here, because our t is going from here. So this is f dash t versus t. Okay. Okay. So we need to check where the function is positive and where the function is negative. So we need to break the function in intervals. So since it's starting from pi by 4, so here will be pi by 4. Okay. So we need to consider this interval. Okay. So I'm going to use another pen. So we can see between pi by 4 to pi by 2, the function is positive because it's above x-axis. And here the function is negative. And here the function is positive. Okay. So we know the intervals of t in which the function is going to be increasing. Do we need to find both? Yes. Okay. So we need to find both increasing and decreasing. So for increasing a part, we can see our t belongs to the interval pi by 4 till pi by 2 union 3 pi by 2 and 2 pi plus pi by 4. Okay. So we need to break the function at these points. Pretty obvious here. So at these 4 points, we have to break the function. Mind it, we don't have to search for t, we have to search for x. So we are going to substitute x plus pi by 4 here. So x plus pi by 4 belongs to the same. So we are going to do minus pi by 4 from everywhere so that we can find the interval for x. So it is going to be 0 pi by 4 union 3 pi by 2 minus 6 pi by 4 minus pi by 4, so 5 pi by 4. 2 pi. So this is the answer of A part, and similarly, we'll see where f dash x is decreasing. Okay. Okay, so it's decreasing from pi by 2 till 3 pi by 2. Okay, only one interval because the rest of the interval is positive. So we need to subtract pi by 4. Then we can get a final answer. So it's pi by 4 and 5 pi by 4. Okay, but as I mentioned previously, you don't have to do this. The graphical method, we can write this, but we can't write these answers directly because it's serious. They expect us to write everything. So the 4 black points which are marked here, we are going to make a table again. Okay. Then x is between pi by 4 till x is then t is between pi by 4 to 2 by 4 pi by 2. Since we are taking t, so we can substitute for x later. Okay. Yeah. And then t is from pi by 2 to 3 pi by 2. And t is between 3 pi by 2 till 2 pi by plus pi by 4. Okay. 2 pi plus pi by 4. So we have to be very careful with the terms you're using. Make this table very neatly. Write ft here. Then assume and then we can make 3 cases, and then we can tell, since this is lies in first quadrant and cos t is positive there, so that's like somehow either by taking some value in between which we know, or by saying generalizing. I mean, we need to give some written proof, and then we have to fill this table, and then we have to write the intervals for t, then we have to substitute x. So that's how we'll complete this solution. So moving on to next question.